Here we want to find the functions f composite g, g composite f, f composite f, and g composite g, and their domains. Well, let's first find a domain of f of x, which is equal to the square root of x. Well, that means that x has to be greater than or equal to 0. So the domain is that you have 0 going all the way to infinity. Okay, and then if we look at g of x, which is equal to the cube root of 1 minus x. Now, since it's the cube root, that means we can put whatever we want in for x. So therefore, x can be any real number. Okay, those are the two functions that are given. So now let's go ahead and find f composite g of x, and the definition states that it becomes f of g of x, where g of x becomes the input on f. So g of x is equal to the cube root of 1 minus x, and so now that becomes the input on f. So we're going to plug in the cube root of 1 minus x. So let's rewrite this as fractional exponents. So the inside radical, this becomes 1 minus x to the 1/3. And now looking at the other, we have 1 minus x to the 1/3, and that's raised to the 1/2. So therefore, you have a power raised to a power, so we're going to go ahead and multiply them. So we get 1 minus x to the power of 1/6, which means it becomes the 6th root of 1 minus x. So now we want to be able to find a domain of the 6th root of 1 minus x. Now, since it's an even root now, we know that 1 minus x must be greater than or equal to 0. So if we subtract 1 to both sides, we have x, negative x is greater than or equal to negative 1. If we divide by negative 1, x is going to be less than or equal to positive 1. And so therefore, the domain is going to go from negative infinity to positive 1 with a bracket. Okay, let's take a look at number 2. Number 2 is g composite f of x. And that definition states that we have g of f of x, where f of x is the input on g. So it's going to be g of the square root of x. So that becomes the cube root of 1 minus the square root of x. So this becomes the cube root of 1 minus the square root of x. Now, the cube root can have any real number in its domain, but what's inside the cube root is 1 minus the square root of x, and this square root of x has an even index, so we need to look at that square root of x to find its domain. And what that tells us is that the domain of g composite f is x such that x is in the domain of f, and f of x is in the domain of g. So what we need to do is we need to look at that square root of x. And that square root of x tells us that x must be greater than or equal to 0, and therefore the domain of that function goes from 0 to infinity. Okay, now we want to find f composite f in part C. So for part C, it is f composite f of x, which the definition states that this is f of x, where f of x becomes the input on f. So remember that f of x is the square root of x. So this becomes f of the square root of x. And now the square root of x becomes the input of that function, so therefore this is the square root of x. Now, just like we did before, this is the same thing as saying, okay, this is x to the 1/2 raised to the 1/2, which is x to the 1/4, and therefore this becomes the 4th root of x. And so now we got to find the domain of this function. Well, the domain tells us that x must be greater than or equal to 0 since it's an even function. So therefore, it's 0 to infinity for the domain. Okay, next, number 4, we have composite G of X, which is G of X, where G of X becomes the input on G. Well, recall that G is the cube root of 1 minus x, so this becomes the cube root of 1 minus x, and then we got to replace that with x into the function G. So it becomes the cube root of 1 minus the cube root of 1 minus x. And so what would the domain of this function be? Well, the cube root of 1 minus x, which is the radical underneath the root, can be any real number. And we know that the cube root can also be any real number. So therefore, the domain can be any real number. Now remember that any real number can be negative infinity to positive infinity.